All right, welcome once again to Physics Meal. Remember, this is a special edition of Physics Meal for students that are preparing for WASI and NECO. So it's a revision series, and we really need to carry out this revision so that our students can excel in the forthcoming examinations. All right, we are still looking at temperature and its measurement, and so far we have been able to define temperature, look at temperature scales, and also we have looked at the upper fixed point and lower fixed point of a thermometer, and we also use that, the fundamental interval, to relate the different temperature scales that we have. Now, we need to look at types of thermometers, but before then, let's talk about thermometric substances. Thermometric substances. Thermometric substances. Okay? Now, there are substances that we base our measurement of temperature upon. There are substances like that. Those substances, they have some properties that change with temperature change. So thermometric substances are substances that their properties change with change in what? Temperature. So we can just put it down. Say that thermometric substances are substances that their properties change with change in temperature. So there are substances that, as temperature is changing, the property of that particular substance is also changing. So some of the thermometric substances that we have include liquid, resistance wire, and gas. 1, 2, 3 are the common thermometric substances that we have. So we have thermometric liquids that their properties change with change in temperature. So we have resistance wire. The resistance of a resistance wire changes with change in what? In temperature. Then also the pressure of a gas will also change with change in what? Temperature. Now, for liquids, we normally refer to them as thermometric liquids. And we say that the best of the thermometric liquid is the liquid we call mercury. Mercury. Somebody will be asking why. There are properties that these thermometric liquids we actually have. There are. So we are going to look at, based on these thermometric substances, we are going to look at the three types of thermometers we want to actually carry out calculations on. So let's use that, and then under each of them we'll now develop some expressions that will help us in calculation. So remember, we said that the thermometric substances, they have certain properties that we change with temperature change. And we say we have liquid, resistance wire, and the and gas. These three. Now, what we should be asking, what property of a liquid will change with temperature change? Or what property of a resistance wire will change with temperature change? And what property of a gas will also change with temperature change? So that will give us the types of thermometer we want to look at. Types of thermometer. Types of thermometer, we have liquid in glass thermometer, we have resistance thermometer, and we have constant gas volume thermometer. So in each case, in each type of thermometer, we have a property that will change. For liquid in glass thermometer, liquid in glass thermometer, for this, what property we actually change? We say the length of the column of the liquid in the thermometer. So if you have a thermometer, there is a liquid inside. There's another tube here, a capillary tube inside. Now, there is a liquid. It is the rise and the fall of the liquid that we can use in the measurement of what? Temperature. So when temperature changes, the level of the liquid will also do what? Change. So if you are increasing the temperature, the length of the liquid will continue to rise. You see that now. If you decrease temperature, then the liquid will now begin to fall inside the thermometer. So it is the length of the liquid column that we use in the measurement of temperature in a liquid in glass what? Thermometer. Now there are various liquids that we can use. Water will not be used anyway because of some reasons. Water wet glass, and also water has irregular expansion. Excuse me. What we refer to as anomalous what? Expansion of water. There is irregular expansion in water. So that's why water cannot be used as a thermometric liquid. So all the liquids used in liquid in glass thermometry, the glass thermometer, liquid in glass thermometer are called thermometric liquids. That's the liquids we use. And the common liquid are mercury and the alcohol. Now it is important that we note that mercury is the best liquid we can use because it has certain properties. Its properties suits the properties a typical thermometric liquid should have. So what are the properties of a thermometric liquid? Properties of a thermometric liquid. Let's quickly look at that. Properties of thermometric liquids. What should be the properties of thermometric liquid? Number one, they must be opaque. For easy readability. 2, they must have regular expansion, unlike water that has irregular expansion. 3, they're supposed to have high boiling point and low melting point to measure very high and very low temperatures. That's 1. 4, they must not wet glass. They must not wet glass. Yes. So these are some of the properties that a thermometric liquid is supposed to have. Now, if you talk about being opaque, so that when they are inside the glass, you can easily read it because of they are dark. You understand? And talk about regular expansion. If it's irregular in expanding, you don't know when it's rising, you don't know when it's falling. If when temperature is rising and at a point the liquid, instead of the liquid column to continue to rise with increase in temperature, the liquid column will now begin to fall, like we have in water. Such a substance is not suitable for the measurement of temperature, so it will not be used as a thermometric liquid. Then every thermometric liquid, a suitable thermometric liquid should have a very high boiling point, so that before it boils, it takes a high temperature. This will enable it to measure high temperature. But imagine a liquid like alcohol that boils at 78 degrees. This is a problem. It means that you cannot use alcohol to measure a temperature of maybe 85 degrees, because at this point the alcohol will do what? Evaporate. At 878 you have started boiling. By the time you exceed the boiling point, the alcohol will now be in vapor. So you cannot really measure the liquid column again, because the alcohol must have turned to what? To vapor. Also, alcohol is colorless, so it's not opaque. So if to use alcohol, we need to color it. And sometimes when you add color to it, it may lose some of its properties. Yes, it may lose its expansion property, and may also the color may serve as an impurity to alcohol and then alter its boiling point. So you see, that's why alcohol is not suitable. It has a good expansion anyway, but it's not suitable because it's not opaque. That's one. Also, it wets glass and it has a very low boiling point. It is only mercury that have major part of the properties of thermometric liquids, and that's why most of the liquid in glass thermometers we have mercury inside. Mercury. All right. So that's it. So these are the properties. Now, we have said that the the liquid in glass thermometer, it is the length of the mercury column that will be used, or length of the liquid column will be used to measure the what? Temperature. That means the length, the length, the length of the liquid column is proportional to temperature. What it means is that when temperature is increasing, then the length of the liquid column will also do what? Increase. So, and if there is a decrease in temperature, there will also be a corresponding decrease in the what? In the length of the mercury column, or the liquid column, if another liquid is used. So we can actually obtain a relationship between the length and the what? Temperature. Yes, we can obtain a relationship. Let's say this is the thermometer scale and this is the length scale. So this is the length and this is the temperature, sorry, temperature scale. Now, we have the upper fixed point for using Celsius and the lower fixed point. All right. Now, how can we measure any other temperature? Let any other temperature we're talking about be just theta. Let it be theta. Then, let the length of the liquid column that correspond to 100 degrees, let's call it L 100. This is the length of the liquid that correspond to 100 degrees C. That correspond to the upper fixed point. And sorry, this is theta. And let the length that correspond to any other temperature theta be L theta. And let the length for lower fixed point now be L0. That's the length for lower fixed point. Remember, if you see a liquid in glass thermometer, we have something like this, and you have that 100 degrees, you have 0 degrees. So the liquid can rise to this. If you measure the length of the liquid, it is L0. Then when the liquid rises to a particular that particular length, that becomes L theta, and then from there this becomes L what? 100. That's what we are trying to say. So if we still carry out the same principle, apply the same principle we use when we are trying to obtain the relationship between temperature scales, we are going to have that theta minus 0 all upon 100 minus 0 will be equivalent, since they are proportional. Temperature is proportional to what? Length. Length at any given temperature minus length at 0 degrees all upon length at 100 degrees minus length at 0 degrees. If you reduce this, you have theta over 100 is equal to length at theta minus length at all upon length at 100 minus length at 0 degrees. That's lower fixed point. Now this the expression that we need. Now let's define those terms. Let's define those terms. So that's what we say that theta is any required temperature. That's the temperature we now want to calculate. L naught is length of mercury column or liquid, length of liquid at lower fixed point. At lower fixed point, or what we call ice point, or the melting point. Then L100 is length of liquid at upper fixed point, or steam point, or the boiling point. Then L theta now is the length at any required temperature. So the temperature of interest now, the length at any required temperature. So this expression is very, very important. We'll just take note of it because we use it for calculation. Now, the same principle will be applied for resistance thermometer and also for constant gas volume thermometer. We are going to apply the same principle. So similarly, let me keep this now. So let me say similarly for resistance thermometer, the resistance of a wire is proportional to temperature. Directly proportional. So what it means that increase in temperature will result to an increase in the resistance of of a wire, and a decrease in temperature will also lead to a decrease in the resistance of of a wire. So if this is still the temperature side, and this is the resistance, all we need to do is to replace this with R for resistance and R. Okay, so we have taken note of this expression. So for resistance we have that. We're going to now have similar thing, that theta minus 0 over 100 minus 0 is equal to R theta minus R0 all upon R 100 minus R naught. So this will give us theta over 100 equals R theta minus R naught 0 all upon R 100 minus R naught. Now this is the expression when we want to calculate any required temperature for resistance in glass, resistance thermometer. We still use the same way to explain or to describe what each symbol stands for. So in this case now I can write this as R naught, which is something as the resistance of a wire at lower fixed point. So R 100 will now become resistance of a wire at upper fixed point, and then R theta now becomes the resistance of a wire at required temperature. Okay, that's the second expression. I believe you have taken note of that. Then we can still go further for constant gas volume thermometer now. For constant gas volume thermometer, so we say for constant gas volume thermometer. The pressure is of the gas is proportional to the temperature. So in this case, a change in temperature will bring about change in what? Pressure. Because we say constant gas volume. That means the volume of the gas is constant. Remember, when we look at various gas laws, we usually, for us to study some property, a given property, we need to keep the rest constant. So in this case, volume is what? Constant in this case. So for a constant gas volume thermometer, the pressure of a gas is proportional to the what? Temperature. So if we still use the same analogy, same principles here, we are going to have, if this is the temperature side, and this is the what? The pressure. Now, we still have 100 degrees as the upper fixed point, any given temperature, and this is 0 degrees. Now we have the equivalent pressure. Pressure at 0 degrees, pressure at any temperature, and pressure at 100. Apply the same principle again, we arrive at theta over 100 is equal to P theta minus P naught, all upon P 100 minus P naught. So that makes it a third expression that we have obtained. And we can still define this the same way we define that of liquid in glass thermometer, the terms, and that of resistant thermometer. So we can actually put this P naught, we call this one P 100, and this is P theta. So this now becomes pressure of a gas. This one becomes pressure of a gas. And this one becomes, again, pressure of a gas at any required temperature. That's for this terms. Oh, that's beautiful. That's beautiful. We're going to go on a break and return to begin calculations on this aspect of temperature and its measurement. I believe you have enjoyed the video so far, so that anytime you see a question in temperature and its measurement, you can actually handle it. So make sure that you continue to follow us until we exhaust temperature and its measurement. When we return, what we are going to face will be calculations all through. We're going to do various calculations in relation with types of thermometer. All right. Till I come again to continue with this, make sure that you continue to study your book. You still have time to rest. You know, when you finish with your exam, then you can rest. You can apply different style of sleeping. You can sleep standing up. You can sleep with one of your legs up. You can also sleep bending down. Any style you want to now apply, you can apply it. But for now, we are in for a serious business, and we must do that business because it is business before pleasure. Thank you, and God bless you.